Hello, this is day 18, chapter 4, and this is unit 3 for us. And this is rational equations. So specifically how to solve an equation that has fractions in it, but mainly fractions that involve the variable being in the denominator. And so there's kind of two types we'll see. And we'll focus on the green lettering first. So this is saying we have like a term in the denominator that is a variable. None of the others are fractions, but the main thing for us is that whatever's in the denominator, if it's a variable, we need it to not be in the denominator. The easiest way to get it to not be in the denominator is to eliminate it. And so essentially, we're just going to, we can get rid of a denominator by multiplying it by itself, or an a that's on top. And really, this is a fraction, and if we're multiplying it by something, that should be a fraction as well. So it's really just a over 1. And what would happen is, if you multiply these together, you get 5a over a, and the a's would cancel each other out. So that's really the first thing we look for, is to what's in the denominator and what do we need to get rid of it. We multiply that to the top of that piece. However, that's kind of cheating. We need to multiply everything by the same thing if we do that. So now this term will get multiplied by an a over 1, and this term will get multiplied by an a over 1. And I'm just keeping them as fractions to be consistent, but really it's just multiplying them all by an a. And what happens is that we can rewrite this. This is a times a is a squared. This term, the a's cancel each other out, so it's just a 5 now. And it equals a 4 times an a, so 4a. And as you can see, this is a polynomial now. There's no denominator, so this is something that should look somewhat familiar. But in order to solve this, we need all of the variables to be on the same side, and hopefully we have the a squared term positive. So I'm going to move the 4a to the other side by subtracting it across. And I'll rewrite it in standard form so it looks nice. And then at this point, this is just a quadratic. We have a number of methods to solve it. Easiest being factoring if it's factorable, and it looks like it is. So we'll say, which two numbers multiply to be -5 and add to be -4. So that's our setup, and then this would be -5 and +1 are the two numbers in combination that work. So -5 times +1 is -5, and -5 plus 1 is -4. So -5 and +1. And then our last step in solving this quadratic is to split these up and solve them separately. So add 5. A equals 5, and subtract 1 in the other one. A is -1. And so you could test these, plug these in. I'm not going to do this every single time, but just for completeness, maybe I'll do it right now. We could check both of our answers, make sure they make sense. If we plugged in 5, we should get equality. This is 5 minus 5 over 5. These were the ones they substituted, equals 4. So 5 minus, that's fractions 1, is 4, true. The other one, if we use -1 minus 5 over a -1 equals 4. We have some negatives to deal with here. 5 divided by -1 is going to be a -5. So -1 minus a -5. And double negatives is plus a positive. So really this is 4 equals 4. So we can see they both work. The plugging it in and checking it will come into play in the next lesson. So just so you've seen it, you can plug it in to check your answer, and it will become somewhat necessary later on, not as much today. Okay, to recap, just on this one, we looked at the denominator. We want it to not be a fraction. The only thing that had a fraction was this guy. And so we multiplied this term by what the denominator was, the exact piece, like a. And then we did that to everything else, and we didn't have a fraction anymore. And it was just a quadratic to solve. Here, and I'll reference the top, in the first problem, number 1 here, we had a single term in the denominator, so we multiplied each piece by that denominator, a. The other type that you may see is when you have fraction equals a fraction. And these ones are nice. We want to see these. They're fun because they relate to something we've done before. This is a case where you have a fraction alone on one side and it equals a fraction alone on the other. So this goes back to, back in the day when you had a problem like x equals, or let's try like that, 5 over x equals, 10 over 13. I'm just a separate example. When we had something like this, the x was in the denominator, but the way that we quickly solved it, whenever we learned this back in previous classes, we cross-multiplied. We said this is going to be x times 10, or 10x, equals 5 times 13, 65. And then we could solve from there, just divide by 10 to both sides. So this cross-multiplication is really useful, particularly here. We don't have to do any of the, what does this denominator need to be multiplied by in order to be eliminated so it's not a fraction anymore. We don't have to worry about that. We can just say, hey, fraction equals a fraction, boom. Keep in mind, these are quantities. So if I did this guy, this is x plus 5 times 3, or 3 times x plus 5, equals 9 times x minus 3. And then this is just a regular type of equation we should be able to solve. Distribute, we get 3x plus 15, 9x minus 27. And this should be old news. I'm going to get the x's to one side, the non-x's to the other, and solve. This is a 6x minus 27, 15. Excuse me, 42 equals 6x, and finish solving, divide by 6. 7 equals x. So it becomes a lot faster, and we were fortunate to not have any quadratics. It was just a regular linear equation with x's on both sides, but didn't take much to solve it. So the key thing here is to recognize when we have a fraction equals a fraction only in the equation, just cross multiply. We've done that before, and it should be familiar. So that's the easy way out, to think of it that way. And here's another example. This looks a lot beefier. However, we should recognize right away we have a fraction equals a fraction. So I don't want to overcomplicate things, just cross multiply. This would be 4p times p is 4p squared. This is 1 times that chunk, and it's all just going to be that chunk. 3p squared plus 7p minus 6. Now, I'm usually a fan, you can do this either way, but I'm usually a fan of taking the easiest path, get this 4p squared to the other side, because it's only one thing to move. However, I really prefer to have the p squared, the term that has the largest degree, to be positive. It's just, it's easier to factor if this is factorable. And so it's just, I'm having a little foresight and thinking, well, it looks like more work to move everything to the left side, but it's going to end up nicer when I have a positive leading coefficient for the p squared. You could do it either way, but you may have to factor out a -1. So in any event, I'm going to move each of these pieces to the left side, and I'm just adding their opposite terms. So they'll cancel out, and I'll be left with a 0 on this side. And see, this one cancels to 0, 0, and 0. But I have to put them on the other side. So this would be minus 3p squared minus 7p plus 6. This is a 0 over here, and we'll just combine like terms with this. 4p squared and the -3p is a p squared minus 7p plus 6. And we can see that this is factorable. There's nothing we need to do to prep it to be factorable. There's no negative leading coefficient because I moved everything to the left side. And so we have 2 parentheses, and the two numbers that multiply to be +6 and add to be -7. Remember, if you needed this, you could make a little t-chart. multiplies to be a 6 and adds to be a -7. Figure out our numbers. Both got to be negative because they're adding to be a negative. So this could be a -2 and a -3. Nah, that doesn't work. -6, -1. Yes. -6, -1, or -1. And then split them up. P minus 6 equals 0. P minus 1 equals 0. And then add 6 to both sides. Add 1 to both sides. P equals 6. And P equals 1. So this was the intro to rational functions. Certainly we can check our answer here. We'll save that for the next day. Suffice it to say we did it right. It'll work. So really we did rational functions, the intro, and you saw two types. The first, if you just have a single term in the denominator in this equation, if it's a variable, you want to get rid of it being a denominator by multiplying everything by that denominator, essentially. Then it ceases to become an equation that has fractions in it and just a quadratic. If you have just a fraction equals a fraction, cross multiply. Makes your life easier. All right, hopefully that worked out, and good luck on the assignment.